So we are going to try to prove if the limit of 2n minus 3 as n goes to infinity is equal to 9/10. If I were to rewrite this as a limit statement, it would say what I just said in words. Limit as n goes to infinity of 2n minus 3 equals 9/10. And the idea there is that as n gets gigantically huge, this expression will spit out values that get closer and closer and closer to 9/10. I hope you can see what a silly idea that would be. If I make n gigantic and I double it and subtract 3, I'm not getting closer to 9/10. But let's look at how to prove it, mathematically. We want the terms of the sequence, which are expressed by 2n minus 3, to be arbitrarily close to this center value of 9/10. So they'll be between 9/10 minus a tiny little bit and 9/10 plus a tiny little bit. And the first thing I would do in a problem like this is these denominators they're killing me. So I'm going to make everybody 10 times bigger. If I make everybody 10 times bigger, I get 9 minus 10 times epsilon less than 20n minus 30 less than 9 plus 10 epsilon. And we're going to set up and solve two separate inequalities. One of them will be 9 minus 10 epsilon is less than this. And the other one will be 20n minus 30 is less than this. So I'm going to actually do this without speaking. And you can follow along or just wait till I'm done, however you want to do it. Let's take care of the green one first. So I end up saying, as long as n is more than 39 minus 10 times a tiny, tiny number over 20, then terms of the sequence are more than 9/10 minus a little bit. Let's try the other side, the red side. If 20n minus 30 is less than 9 plus 10 a little bit, to get the n by itself, of course, I'll add 30 to both sides. Divide both sides by 20, and this tells me that n less than 39 plus 10 epsilon divided by 20. So for n values that are less than this value, whatever this ends up being, this will change. Like if you told me a value for epsilon, I can get a number for this, right? So if someone came by and said, I want to be within 1/5 of 9/10, I can plug in 1/5 for epsilons and get a number. So I want you to think of this as it's just some number. It ends up being some number. It changes based on how close somebody wants to be, but it's some number. And as long as n is less than whatever that number is, our sequence is this close to 9/10. Now that's a problem, because that means that, yeah, there'll be times when there are values for n that are large enough, for the n's that are bigger than whatever this number is, where this is pretty close to 9/10, but at some point, it's no longer going to be really close to 9/10. Because we have an n less than in one of the inequalities, it means that this limit is not correct. That the limit as n goes to infinity of 2n minus 3 is not 9/10. What is this limit as n goes to infinity? I don't know. We'll learn about that later on. But all I can tell you right now is if you wanted to prove to somebody that it wasn't 9/10, aside from appealing to their common sense, this would be the math to do it. Yeah. Hope that makes sense.